I mentioned that a lot of this passing a checking account to something that's expecting a bank account has to be with pointers. The reason is because when you copy solid objects around, you get something known as slicing. If I take a checking account that has a balance and who owns it and all that contact information, as well as an overdraft limit, and I copy it into a bank account object that doesn't have a place to keep overdraft limit, the absolutely best thing that can happen is that the overdraft limit will just get thrown away because there's no place to put it. I mean, the worst thing that will happen is some kind of runtime error. So you can take a checking account pointer and give it to something expecting a bank account pointer, that's fine. But if you take an entire solid checking account and give it to something that's expecting a bank account, you're going to lose some of the checking account information. That's not necessarily an error, but it is if you then want to try to somehow get some virtual behavior where you'll see the use of the derived class's member variables. There is no derived class anymore, and those member variables are gone. Similarly, you can't take a bank account and copy it into a checking account because there's information missing from that base class that's needed in the derived class. We do simple demos where we declare things and set them equal to things, but as I've said many times before, what really happens in live C++ programs is that things are being copied back and forth to functions because functions are what your app is built of. If your function takes things by value and the types are different, either the copying will entirely fail or slicing will happen, depending on which direction you're going in. Slicing's bad because you're throwing information away, and certainly copies failing is also bad. And that's why it's so common not to pass by value, but to pass by reference or to use pointers. References use the same syntax as solid objects, use the dot instead of the arrow. Some people find them a little easier to read. Polymorphically, there's no real difference between references and pointers. The same rules apply about, I'm expecting a bank account reference. Sure, here, have a checking account reference. And that's why people use references and pointers when they're passing things around to functions. Let's go back into this same project and add some code that copies some objects around so you can see some slicing and some compiler error messages. In the interest of not watching me type, I'll just quickly paste this in. Here I'm creating a local person in local storage, passing the parameters into the constructor as always. This is fine, there's no problem with this line. On the next line, I'm trying to create a tweeter locally and initialize it by just copying that person into it. And you see that the error here is no suitable user-defined conversion from person to tweeter exists. You know, it can make a person from a person, it can make a tweeter from a tweeter, but in order to make a tweeter from a person, I would have to write some code to teach it how to do that. Because what are we going to use for the Twitter handle? So let's come at it the other way then. Since that's not going to work, let's make a local tweeter. And make up a Twitter handle. Again, apologies if that's anybody's real Twitter handle. And then let's make a person from that. And then I'll use its get name. What actually happens when this runs is that we copy the first name, the last name, and the arbitrary number from local T2 into local P2 and throw away the Twitter handle since we have no place to put it. And when we call get name, it calls the person version of get name. Just says local tweeter. There's no handle. That's because the handle is long gone. Now, one way around this would be I could have made this a person pointer. I could have asked for the address of local 2. And I could have switched from the dot notation to the arrow notation. That'll compile. But it's a lot of work, especially if I had more than one line of code. Plus, that's a raw pointer. Maybe I should be using a shared pointer. Here's a nicer way to get polymorphism while still keeping this syntax. I can make this a person reference. One character I type. Run it. Now I get the tweeter version of the function, even though I use the person reference. And that's because references are polymorphic in the same way that pointers are polymorphic. And I didn't have to go around with stars and ampersands and arrows and all of the things that start to get people sort of punctuation tense. It's okay. Just make it a person reference. It's a polymorphic reference. It'll use the tweeter get name when I call the function. Same thing happens if you take a function that takes a person by reference and you actually give it a tweeter, and then it happens to call some member functions of tweeter. That's what will run, tweeter member functions, even though the code that's running thinks it's calling person member functions. Of course, they have to be functions that were defined in person, and furthermore were defined as virtual in person, not just an extra thing like tweet that you added to tweeter. It has to be something from person like get name, but then you will get the behavior you want.